So we're going to do activity 3.4. This is new stuff. This is algebra stuff. So we're going to do all the problems together on this one, okay? So basically what we're doing is we're looking at a problem around having a swimming pool, right? And the swimming pool has, at one point right here, so we definitely don't have a line that's going on forever, but at one point right here, we have some negative values, negative on the x-axis, negative on the y-axis, and then a line that goes through with some points that have that end up on a positive. So let's read the problem and see what it's telling us. The graph shows the water level of a pool. The x-axis represents the time in hours, and the y-axis represents the water level, okay, in inches. The origin, so 0, 0 is the origin, okay, that represents 3 p.m., and then it represents the desired water level. So if you have a pool, you have like a level that you want to be at. Don't fill over this line, but you don't want to be under that line either. And that's basically what that is right there. And at 3 o'clock, the water level is perfect. So I'm thinking to myself, well, what could be happening in this? Well, at some point, we have less than desired water level, and some we have. And then as the time goes on from left to right, we go over the desired water level, right? So I'm thinking to myself, okay, well, maybe up until this point, kids were playing in the pool a bunch and the water got low. And then it started to rain. And then over time, the water level went up because the pool collects the rainwater. So it rained for a long time, and then the water level got above the desired water level. So that's the story that I made up for this, okay? You can make your own story. The first question asks us to label the graph of the independent and dependent quantities and their units. So it says right here that the x-axis is time in hours and the water level is inches. Now it's got 5 points on it. 9, 6 right here. 6 and 4 right here. 0, 0, the origin's a point here. Negative 4.5 and 3, and then negative 9 and negative 6. I'm looking, wow, that's just opposites of that other point. So that's going to tell me something, right? And it wants you to give you a meaning for each one of these points. Well, the origin, it already gave us the meaning. The origin means it's 3 p.m. because the origin represents 3 p.m. And then it also is the desired water level. So the origin's 3 p.m. desired water level. So that means at 3 p.m., the water level is perfect. That's what that point means. So I'm going to start here at negative 9.6 or negative 6. So negative 9 would not mean 9 o'clock. It would mean 9 hours before 3 p.m., which would mean 6 a.m. And the water level is 6 inches under desired, which is less. We can just call that full, right? So 6 inches less than full, and it's 6 a.m. because it's 9 hours before noon. 9 minus, or 12 minus 9 is, I'm sorry, 3 a.m. Boy, you guys would get a lot of candy on me lately because I'm making a lot of mistakes. 3 a.m. At 3 a.m., it was 6 inches less than full. Now, the next point is negative 4.5 and 3. So if I take away 4.5 from 12, it's giving me 7.5. Well, that tells me it's 7:30 because I know half of an hour is 30 minutes. So at 7:30 a.m., there was 3 inches less than full. And now I'm going over here to positive 6 and 4. And 6 plus noon would be 6 p.m. So 6 p.m., there's now 4 inches over desired or over full. It's the first time we're over full. And then at 9 plus 9 hours, we add 9 to noon, and we get 9 p.m. Now we're 6 inches over full. So as we went on from this point on the left, 9 hours before to 9 hours after, we went from 6 inches under full to 6 inches over full as it rained. Now, we're going to use the same graph to answer some more questions, okay? So we have to find out what is the rate of water going into the pool. And we're going to use something new it's called the slope. And we calculate the slope by going the rise over the run. The rise is just how much we travel on the y-axis, and that could be positive or negative. And then the run, which is how far we travel on the x-axis. So if I'm going, let's say I'm going from the origin, and I want to track my point to here, I can just simply go from here. That's 6 over, and that's my run, and my rise is 4. So the slope of this line would be 4 over 6, or 2/3. Okay. Now, here's the trick. It shouldn't matter where we go. We should always get the same slope. So if I go to this next point right here, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9 is my run, and 6 is my rise, I can find my slope by going 6 over 9, which also equals 2/3. Or I could even go from -9, -6 to +9, +6, and my run would be 18 because I'm doing absolute value. 9 plus another 9 is 18. And my rise would be 12 because I'm using absolute value. I'll go 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. And 12/18 equals 2/3. So no matter what, I always get the same rate, and that is 2/3 is my slope. And all that means is that for every 3 hours, I add 2 inches of water. And that's my slope. Okay. Describe a situation that would match the graph. I started with that because I wanted us to be able to visualize it. And I'm just going to write pool is low on water at 3 a.m. And that's what we found here on our graph, right? At 3 a.m., it started to rain. It rained until 9 p.m. and went from 6 inches less than full to 6 inches over full. That was just our little story to match with it. So now you got to write an equation for this. How do we figure that out? Well, the equation that we're going to use is going to be called slope-intercept form. Okay. Where our y value and our x value are going to be dependent on each other. And whenever you use slope-intercept form, we always isolate the y. Okay. Now we're going to use this and this. Okay. So m equals the slope. B equals the y-intercept. That's why we call it the y slope-intercept form, because we're finding the y-intercept. So anytime you have a graph like this, you can just find the slope and where the line crosses the x-intercept, and you'll find the equation for the line. So ours is simply y equals 2/3, because that's what we found our slope was, using the difference between 3 different points with rise over run, times x, plus the y-intercept, which is 0, because our line goes through the origin. So our y-intercept is 0. So that means at any time, all we have to do to find y is take 2/3 of x. And we can try that, right? If we have 9, x is at 9, we take 2/3 of it, and y equals 6. And that point matches up on our line. Okay. All right. Okay. Now, why does the graph stop rather than continue indefinitely? In our situation, because it was raining. and raining starts and stops, right? But could have been any situation. You could have turned on the hose to fill it and then forgot about it and overfilled it. But this is definitely a problem that says we're putting in water from 3 a.m. to 9 p.m., whether it's rain or anything else. That's why it doesn't go on forever and ever. Using any of your mathematical tools, determine the time when the pool is 3 inches above. That means y was 3 above. So what we're basically saying, I'm going to use my equation, y equals 2/3 x plus 0. Now we know the y because it's 3 inches above the desired level. So 3 equals the slope 2/3 times x plus 0. Now I want to isolate x. So I'm going to add 0 or subtract 0 from both sides, right? Because I want to get rid of that 0. Minus 0, minus 0. Didn't even really have to do that because we know that plus 0 doesn't change it. So now we have 3 equals 2/3 x. Now I want to get the x by itself. So I'm going to multiply by the reciprocal, something we did before we went to distance learning. So all I have to do is multiply both sides by 3/2. 2/3 times 3/2 times x equals 6/6 times x, which equals just x. And then 3/2 times 3 equals 9/2. X equals 9/2, or x equals 4.5. Is this exact? Yes, because we solved it mathematically using our equation. Let's check our work. If I were over here at 3 on my y-axis, it would intercept here, which is right at 4.5. All right, I understand this is a lot. It's okay. If you have questions, let me know. This is an introduction, will not be on the assessment. I'm glad you followed along.